So we've got about, I don't know, 17 days left to PiWars 2018 now. So I've been working on this for quite some time. This is going to be an attachment for our robot. So I haven't got the robot here, so I can't show you how it attaches, but essentially we've got a universal mount system on the front of our robot. So this red part slots into the front of the robot, so that just slides in and can be secured with a couple of screws. So this is a bit of a beast of an attachment. Just the camera. So this is for the Nerf or the duck shoot challenge. So we've ripped apart a Nerf gun. So we've got the Nerf motor there. All this grey, orange and yellow is all 3D printed. It takes the standard Nerf cartridge, and there's a trigger mechanism in here. So we've got a servo here which feeds the dart into the Nerf motors, and the Nerf motors fire it forward. So that just slots in there. You can see that. So that will just slot onto our motor, onto our robot, and give us capability for shooting Nerf pellets. So all this takes a little bit of control. So in terms of the Pi. So what we've got here, so we've got the wires here to control the motors. They'll be running at 6 volts, but they can draw quite a lot of current. I've done a video on that previously. If you just let the motors spin up on their own, they can draw up to about 2.5 amps. So I wanted to limit that so we don't brown out the Pi. We've also got the servo for the firing mechanism, and we've got the servo for the elevation adjustment as well. Any turning will be done with the robot. So to get all this to work, I come up with this. So on here is essentially 3 adjustable regulators. So one of the regulators just gives us 6 volts. So I'll be feeding into this 14.4 volts from the batteries on our robot. So 14.4 volts in. One of the regulators gives me 6 volts for the 2 servos. Another regulator is in current limited mode, so this will limit the current to 1 amp. So that will give me 14.4 volts but 1 amp limited. In fact, it drops a couple of volts, so it's probably more like 13 volts out of there. But then I feed that 13 volt 1 amp limited into another regulator to get me another 6 volt out. And it's so essentially I've got 2 supplies, one 6 volt standard 6 volt supply for the servos, and I've got a 6 volt supply 1 amp limited to feed the Nerf motors. So what happens when you turn that on is basically you spin the motors up, and instead of them going full pelt, drawing 2.5 amps, it will spin up until it pulls an amp, and it will just stay at 1 amp constant current. The motors will spin up. It takes a couple of seconds to spin up. Once they're spinning full speed, they only draw about 600 milliamp. So they can spin at full speed, no problem. It just slows it down, get into full speed, and hopefully it'll be a bit better for the current capability of the robot. So we've got to get that to feed that somehow. The robot's already quite full. We've got a hat on the robot, a PCB hat on the Raspberry Pi, which gives us all our outputs, so all our I2C for the various sensors and other bits and pieces. So you can't use a breadboard. Well, you could, but it's quite messy. This year we're trying to make a concerted effort to keep all our wires tidy. Traditionally we've been quite messy robots, so we want to make it look a bit smarter this year. So I prototyped it onto a strip board, and that works just fine. But again, it's still a bit big, and I wasn't sure where I was going to put it. So I've done a couple of PCB designs. So what I thought, looking at this, we've got a little bit of room either side this about here. So I thought, what if I turn this bit of Perspex into a PCB? I wonder if I can fit all that on there. So I played about with it. It was quite tight for room, but I thought I'd give it a go with surface mount. Now, I've never designed a PCB as surface mount before. It's always been through hole. I've never soldered surface mount before, so this is all new. A couple of days ago, we got delivery from All PCB, coming from China. So these took about a week to get here. So they look quite nice. I've done a few continuity checks and it all looks to be working well. So you can see this PCB, it's the same shape as that base plate. So the idea is we could, them holes match up. I was just able to export my model from Fusion, export the DXF outline into the CAD software to give me the exact same size. The only difference is the Perspex is 3mm thick and the PCB is 1.6. So where these attach here, I just need to either recut these with a smaller slot here, or work out a way of packing them. And also, because these are milled, I don't know if you can see, there's a very slight curve. They're not laser cut, so it's not sharp, so it's a very slight curve there, so they don't really push in enough. It's probably about a half a mil shy, so I might just have to get a file onto that. Pretty strong, so I'm pretty sure that will be able to withstand any forces. So what I've got on here, so this is going to attach onto the robot with these universal mounts. Let's put that on there, just to give you the idea. And that's on there. So it's going to attach. Does it fit? I think I've got these the wrong way around. Might have to do a bit of filing. Yeah. That can be persuaded, so that will go on there. That will slide on to the robot in exactly the same way as the original mount. That will be bolted onto the PCB. So this side we've got the headers for, we've got a laser mount on the front. So we've got a attachment for the laser, the motor pin out, and the two servo connections in there. So that's all the connections over here. All this side is essentially everything on there. So I've managed to squash that down pretty small. We've got the three, I went for surface mount, the LM317 voltage regulators. Two of them get quite hot in use. I'm hoping they'll be okay because they're not used for very long periods of time. But what I did put in here, I put the surface mount footprint in and also the through hole footprint. You can see the 3 holes there as well. So there's 2 footprints on top of each other, so if they do get too hot, I've got an option of just using the standard through hole LM317 as well. So, but then I wanted to find a nice way of attaching this to the Raspberry Pi without having to attach wires. So what I've got here is a 2x8 standard 0.1 inch pitch header. So there's going to be a socket on the top here, and on the robot there'll be a pin header. So the pins will come through the holes in the bottom of the PCB and connect with the socket on top. It's very similar to the way that the Raspberry Pi SenseApp header works. If anyone's got a Raspberry Pi SenseApp, the PCB is on the base and there's a surface mount header on the top, with holes in the bottom of the PCB, and then when you pull it on top of the Raspberry Pi header, the pins go through the hole into the PCB on top. So that's the PCB, and today I've had a couple of deliveries, so let's see what they are. I ordered them from Farnell's. I've got this gigantic, you can see that, gigantic Toblerone box here. So this is hopefully the headers. They had to come, although I ordered Farnell's in the UK, they came from the United States somewhere. Yeah, I can't see where it's come from. Let's go and get a knife, we'll open it up. Right. Sorry my knife's not as big as Dave Jones. Let's see how we get on. So let's see what's in this. I'm not expecting it to be much. So the reason it's so long, they've sent me a standard tube, which is normally full up with components, with just, I think I ordered 10 of them. So we've got a tube, and hopefully in there my little headers, my little surface mount headers. So there you go. So there's holes in the bottom. So this is going to test my soldering skills, I reckon. So that will surface mount on there, and my pads and the pins line up, which is nice. So there'll be a pin header underneath on the robot. The pins will slide through there, connect with that, and connect everything together. So what else? So one more delivery. So this was from the UK. Farnell's again. So, oh geez. So this is my 100k resistors on a tape. So I've got to solder them on. That's going to be fun. I think the resistors are on the back of that. There you go. And that's going to be interesting. So yeah, lots and lots. Transistors, is that, I think? More resistors. More resistors. And that, I should have some 317s, they're diodes. Where's my 317s? Ah, that's that first one. Yeah, so that's the surface mount 317s in there. Okay, so now the scary part. I've decided to do this surface mount, which I've never done before. These things, I went for the imperial measurement for these surface mount components, generally 0805 components, which I thought was a bit of a, you can go smaller, but I thought that was quite a reasonable size. But seeing them in real life now, they are tiny. So here I've got the 330 ohm resistors. I've got two of these in positions R2 and R6. So we've got R2 here, and R6 is here. So I think my I'm just using a conventional soldering iron here. I think the easy way to do it would be a bit of paste and a hot air gun, but I haven't got that, so I've only got soldering iron. So I think my way of doing this will be to tin the pads with a bit of solder. I should also have some flux, but I forgot to order it. So I'll be tinning the pads, or I think I'll tin one pad. I'll get the component in a pair of tweezers, lower the component on with the tweezers whilst heating the pad with the soldering iron. Get it in position, take the soldering iron away, let the solder cool down, and then solder the second pad. So that is the theory. So honestly, I've never done surface mount before. So let's see what these things look like. So there are resistors in there apparently. If I have, is that any better? Probably not. And the marking on these is 331, and I believe the way surface mount components done is 33 is 33, and then the 1 on the end is how many zeros. So 33 and then 1 0, so 330. So there's a bit of tape over this, so I need to carefully pull that back without dropping them all everywhere. So I need 2 of these. I'm going to get one out initially. They are taped on nice and tight. So this, if you don't know, this is a bit of plastic. This is designed to go into a pick and place machine. The holes will pick up in the sprockets of the machine, so it'd feed in, pull this tape back, take one of the components out, place it on the board, which would have solder paste on it, so the solder paste would hold it in place. It would do that for all the components on a particular board, and then it would go through an oven, which would melt the solder paste and effectively solder it all into position. Now, this isn't what I was anticipating being hard bit, so I'm just going to pause it here a second. So I've managed to get that tape back, so I'm just going to tip one of these out. Oh Jesus, can you see that? That is the resistor. Sorry, you're probably not going to be seeing this awfully well. I'm just recording this on my iPhone. But that goes on there. If you can see that. Right, now let's solder it. So let's get that out of the way. That's lost forever. So literally this is just a standard soldering iron, quite a big tip on it. I might have to change it, but we'll see how we get on. So I'll start off tinning just one of these pads. Oops, they're both tinned. Find that resistor, where did I put it? Here we go. R6 330, that is the correct place. So well, I do believe that's pretty rubbish actually. I definitely need to only tin one side. What happened there is because I was tinned both sides, when I put the first side down it was sitting up on the cold solder on the other side, so it's connected but it's sitting up on one side. I don't know whether I can get enough heat in that to measure. I think that's done it. Now, since this is the first one, I'm just going to measure this with a meter. Just to make sure I'm not wasting my time. So that resistor is connected to that pad. It's connected to ground. Which one of these is ground? Alright, that's measuring 330 ohm across the resistor. No, it's not made contact with one of the pads. So let me try that. I'll mess about with this. I'll get back to you. Oh boy, that was harder than I thought. So I've got that one resistor on there. It's not pretty. The first resistor I broke trying to push it flat. So I took it off, cleaned all the solder up, got a new resistor out. And that's now measuring 330 ohms from the pad next door to ground. So that's that one's working. Just a whole load more to do now. So I'm not going to bore you all watching me do the whole thing, because you probably can't see an awful lot. But I'm just going to crack on with this now. Okay, so it's another night. I soldered the board up last night. It wasn't too bad once I got into a rhythm. The best way I found of doing it was to touch a bit of solder onto one of the pads, heat that pad up while with a small pair of tweezers slide the component onto the hot solder, and then take the soldering iron away, wait for it to cool down, and then tap a bit of solder onto the other contact, and I got there in the end. So after that soldering, most of last night was a bit of troubleshooting. I found it wasn't working quite as expected, and then tonight I've been doing more troubleshooting, and I found out on this version of the board I've missed a track out from one of the I just missed a track out, so I've just bodged the wire in there. and it's now working. So I'm feeding 14.4 volts in here. I'm just simulating the connection I'm going to have on the robot. Got my power supply set to 14 volts, and there's a GPIO pin which will trigger the transistors to turn the motor on. So this wire here is I'm just taking one of the 6 volts off of the servos. There's a 5 volt logic, so it's not quite right, but it is working. I'm supplying that 6 volts to a 5 volt rail which supplies the transistors. So when I touch this on this pad here, see the motor spins up. So this is effectively when we tell the GPIO to go high. If I hold it on there properly, let's poke it in the hole. It's in there, and the motor spins up. Now if you watch the current on here, which is the middle row, so it's pulling 0.026 amps at the minute. I'll put that in there. It doesn't go above 800 milliamps. Which is as designed. If I'd just put 6 volts straight onto that motor, it would rev straight up to about 2.5 amps. So that circuitry is doing what it's meant to be doing. So this is, I've actually got another board on order. I ordered at the weekend, and I've just checked the design, and that wire isn't missing on the second board, so I'm not sure what went wrong there. But yeah, all in all seems to be working. Quite happy with the board. Managed to solder it all up. So yeah, I'm gonna order some more boards now.